So this is kind of like the foundation for being able to do the volume problems effectively and other applications. So we want to make sure that we're good at this. So let's say we want to find the area between, let's see, let's do x equals sine of y and x equals 2 over pi y. Okay. So what do we do first? You guys remember? We draw a picture. That's right. Okay, so we draw a picture. Now let's color code these here. So let's say this is the blue. So x equals sine of y. Well, have we ever graphed x equals sine of y before? Never, right? We know how to graph y equals sine of x, though, right? So if we just kind of imagine, I don't know why I'm doing it tilted there, but so if we imagine y equals sine of x, it looks like this, right? And how long is, what's the period of sine of x? 2 pi. Okay, good. So this would be pi. This is 1 minus 1, right? Okay, so let's say we want to translate that into x equals sine of y. Well, it's easier than you think, because, so here notice, what is x going to go from and to? Minus 1 and 1, right? Exactly what y does over here. Now x is going to go between minus 1 and 1. And then what about y? From minus 2 pi to 2 pi, right? Okay, so let's see. Let's say this is minus 2 pi. And let's say this is 2 pi. Okay. So probably be helpful to just kind of think through a couple points here. If I plug in minus 2 pi for y, what do I get for x? I get 0, right? Okay, well I heard everything, but
Well, it's just going up the y-axis instead of sideways along the x-axis.
Yeah, it's just along the y-axis.
well, yes, but yeah, I mean if you tilt your head a little bit, you pretty much have it. But I guess instead of just graphing it and telling you what it is, probably a good idea to think it through a little bit. Yeah? Don't you think? Yes? Okay. All right. So think of it like you normally do, you know. So the only difference is here we're plugging in y values and then we're getting x values. Yeah? So when y is 2 pi, sine of 2 pi, or sorry, minus 2 pi is 0, right? So here it's 0. And then 2 pi it's 0. And then at 0 it's going to be 0, right? Yes or no?
Yes.
You with me? Okay. All right. So then what about at when y equals 2 pi?
It's 1.
Nope.
Negative 1.
Nope. What's sine of pi? 0, right? Okay, good. All right. What about at pi over 2? 1? Okay, so it's over here, right? Okay, good. All right, and then at 3 pi over 2? X is equal to minus 1, right? So what does it look like on, so it looks like, looks like this, and then it goes down like that, and then back up. Does that make sense? Okay, so all we did is we just kind of plotted points, right? So notice the only difference is we are, and here we'll just graph one more. We're plugging in the y value and we're getting the x value back, right? So it's a little bit different, but it's not really that different. And you can see if you tilt this, the y equals sine x graph in the right way, you get x equals sine of y. Okay, now what about x equals 2 over pi y? What does that look like? That is yeah, it's just a line, right? So, same thing, not too difficult. Notice, well, all you need to graph a line are 2 points, right? So, we know it passes through the origin, right? 0, 0. That's easy enough. What would be another point that we can put in here? There's a lot of easy choices here. What about, for example, y equals to pi over 2? What would you get? If I plug in y equals pi over 2, I get x equals 1, right? Okay, well, where's that? That's right here. So that's all I really need to graph a line, right? Well, that wasn't a very good job right there, that last part. Something like that. Okay. Okay, so let me erase this so that I can do a slightly better job. So this is pretty common to do a bad job graphing, I mean, especially for me. But that's a pretty good. Okay. All right, so now since we're trying to figure out what the area between the curves is, what's the area that we're looking at? Can you see?
Yeah.
So it's that right there, right?
Yeah, that.
And that? You guys agree?
I thought it was a little one.
Okay, good. All right, I'm glad you guys thought it was the little ones because it is not what I just drew. So it has. So one of the really common mistakes that I see is students will accidentally use the axes as boundary lines. So unless you're specifically told, for example, oh, x equals 0 is one of the curves that you want to find the area between, then you do not count the horizontal axis as one of your boundaries. Does that make sense? So even if it kind of looks like the horizontal axis or the vertical axis should be a boundary line, it isn't unless you're explicitly told. So what is the right area? So it's this area right here. Okay. All right, good. All right, so a couple observations here. So typically, how many integrals, I'm going to erase this just so that I have more space here. How many integrals would I need for this situation since there's an intersection point in the middle?
1 because it's multiplied by 2.
Right, so typically you would need 2, right? But notice there's a symmetry here. So this is something that you want to watch out for. So notice the area is symmetric. If you have symmetry, then use that to your advantage. So instead of doing, so let's just write this down since it's the first time that we've seen it. So instead of the area equaling to, so let's say we were going to do it the long way, separating it into 2 integrals. What would it be? If I'm going to do it as 2 integrals, where's the first area? Well, what can I tell you?
It's not that full area though.
So so you'll notice this happening more and more. So we need to decide if we want to integrate with respect to x or we're going to integrate with respect to y. So if your functions are given as functions of y, pretty much almost guaranteed that you're going to be integrating with respect to y. It rarely will be easier to switch. Because, for example, so think about it here. You have x equals sine of y. If I tell you you need to integrate sine of y dy, or notice if I solve for x, I would get inverse sine of x dx. If you compare those two integrals, which one's easier? Sine of y dy. There's no contest. So there's no reason why you should fight having the integral with respect to y. So I know it's different than you're used to, but often you need to do it that way anyways, because the alternative is way harder, right? So if I have to integrate this, how many of you guys know how to integrate that? Nobody should know, unless you've taken Calc 2. Okay, so, all right, so...
Would your limits be negative pi over 2 to 0 and then 0 over pi over 2?
Right, so that's the thing, is that since our limits of it, so we're going to be integrating with respect to y, so then what we want to do is look at the limits of integration along the y-axis. So here, notice it's going to be, it's from minus pi over 2, right, to 0, and then from 0 to pi over 2, right? And notice these are y values. Now, what am I going to integrate? What's the first one going to be? So remember, it's the larger minus, the greater minus the lesser. So if, in this case, where the greater?
Sine of what?
No. So you want to look at it as, so notice this, since the values of the function are the x values. So where are the greater values? The greater values are the ones further to the right, right? These are the greater, these are the lesser, right? Because you're looking at the number line, the horizontal axis. Those are the values of the function. Does that make sense? So, so for the very first integral from minus pi over 2 to 0, I'm looking at this one right here, right? So which one's greater? The one on the line, right? The red line, which is 2 over pi y, right? That one's greater on this for this section right here. Because it's further to the right. Does that make sense?
And that's because it's with respect to y.
Exactly. Yep. Because what is the value of the function here? It's the x value, right? The x value is the value of the function. So you're plugging in y, you're getting x. X is the value of the function, right? So it's flip-flopped. So you got to be careful. So it's 2 over pi y minus sine of y dy, right? Plus what? This time it's sine of y is the greater, right? Because notice this time it's further to the right. The sine of y minus 2 over pi y dy. Okay. So again, notice that like we said, instead of doing that, what are we going to do? So instead of this, because of symmetry,
Note the areas are equal.
so the area is going to be twice the integral from, and then you pick whichever one you feel like. I would say from 0 to pi over 2 is probably a little bit nicer. So if I'm going from 0 to pi over 2, what would that be? That would be sine of y minus 2 over pi y dy. Does that make sense? Yeah? So anytime you can use symmetry to your advantage, you should, for sure. Okay, so any questions to this point? Or are we okay? All right. Well, I'm going to let you guys finish this. I think probably we would benefit from practicing the setup instead of having to go through the whole thing, because you guys already know how to evaluate the integral, right? That's a pretty easy one.
Why'd you put the sine y minus 2 pi y instead?
You just it doesn't matter which one you pick. You can pick whichever one you want. I just found that one's easier because it doesn't have negative signs. Yeah? Okay. Is that a good plan? To leave it off and then you guys do it later? Yes? Okay. All right. So let's do another one then. I'll give you guys one to try. Deal? Deal. So, this one right here, we got, what was it? 1 minus pi over 4, right? That's what we had said. So sometimes you have to decide whether you want to integrate with respect to x or with respect to y. So, for example, this one, so if we were to find the area by integrating with respect to x, what would it look like? So we're not going to actually evaluate it, but what would be the integral? It would be the integral from x equals, so let's do twice the integral from where to where? What would it be in this case? Well, no, because if we do it from minus 1 to 1, we would, let's use symmetry again. So 0, well, let's do 0 to 1. From x equals 0 to 1, so we're going to do this section right here. All right, so now if we're integrating with respect to x, though, then this function has to be a function of x, right? So it would be y equals to pi over 2x, right? And then this one would be y equals inverse sine of x, right? Does that make sense? Okay, so what would be the order down here on the integral then? Exactly, it would be pi over 2x minus inverse sine of x. Why? Because pi over 2x is greater, right? Does that make sense? Yeah. Okay. And let's just verify that that actually is the same, just for me to prove to you guys that it is. Let's ask Wolfram to do it for us. So it was the integral from 0 to 1 of pi over 2x minus arc sine of x. And we should get 1 minus pi over 4. Is that 1 minus pi over 4? It is, right? 1 minus pi over 4. So exactly the same thing. So, okay, well that's fine. But notice if we were to actually evaluate that integral, that would not be a fun time, right? So this one up here is easy to do. We just decided to not do it because we want to get to do more problems. But the second one we can't really do easily at all, right? So you often will be faced with that choice. So in this one, you have that choice, because in this case they're all lines, so it's easy to switch from one to the other. So there isn't really something preventing you from doing one or the other. Then at that point it becomes which one is easier to do, and it's based on what the area looks like, basically. So maybe when you were, if you had done any of these before, you might say, oh, well, we don't even need to draw the picture. We just, plug them all in and then kind of, it'll all work out. But notice with this one, if you don't have the picture, would you be able to figure out from where to where to integrate, or which one's greater, which one's lesser? What do you do? Not really, right? So when you look at the picture, it's a little bit confusing, right? Maybe? I think. Do you guys agree that it's a little bit confusing?
Yeah, I'm confused by just like I'm looking at it because you see like the three different functions, and it's kind of weird to choose.
Yeah, so it's because it's kind of like a triangle, right? So there's
Yeah.
3 lines, and then you're like, oh, well, okay. So let's try. Let's see. So let's say, let's take a look at it together. So x equals 12 minus y. So let's see. What would be, so
0 at 12 on the x-axis.
So, okay, so x equals 12, y equals 0. That's 1 point. What's another point?
0, 12.
0, 12 on the
Y-axis.
y-axis. Okay, so that's good. Let's see, that's about 12. All right, so let's say, so that's 12 minus y. And then x equals y. Well, that just looks like that, right? So that's x equals y. And then x equals 2y.
Steep slope.
8, 4.
Which one?
I did 8, 4, 0, 0.
Okay. Yeah, I mean, that's fine. But it looks like that, right? Okay, so what's the area that we're looking at? Well, there's a whole bunch of triangles that I see, but which one?
The little triangle right in the middle.
The little triangle right in the middle. So what you're looking for is the area between all of the curves. And like I said before, I mean, what you need to imagine is you need to imagine this. So I'm going to put them back, but look at this. This is what you need to imagine. Is it clear what the area is now without those lines there? It is, right? So that's what you want to imagine, that the axes are not really lines that you want to look at. You remove them from your brain. I don't know what happened. Oh my goodness. Should report this as a bug to the app maker. Okay, well. All right. So x, y. Okay, so the area, like we said, is this right here. Okay, so all right. So we need a couple things. We need to know these intersection points, right? So we need to know what that is. We need to know what that is. We know this one, right? That's 0, 0. So the intersection points. All right, so how do we find the intersection of the orange and purple lines?
12 minus y equal to
Yeah, you just set them equal to each other, right? So in this case, it would be y equals to 12 minus y. And if I do that, what do I get? I get y is equal to 6. Okay? So this is 6. And then what is x? Where do I get that from? Yeah, plug it into either one, right? Okay, so either 12 minus y or y. Sorry, x equals 12 minus y or x equals y, either one. Okay, and then, so that's fine. That's one of them, right? And then we have another one. where the purple line, 12 minus y, we want to set that equal to the green line, right? 2y. So what do we get there? Y equals 4. And when y equals 4, what is x in this case? 8, right? Why? Because x is equal to 2 times y, which is 8, right? Okay, so that's not particularly difficult. That's all fine and dandy. But we need to turn this into an integral. So I'm going to erase this so that we have enough space. And like I said, you have choices. So let's do both ways because this one is easy to do both ways. So area with respect to, which one should we do first? Y. Okay. So what would that be? That would be, well, how many integrals am I going to need? Nope. You need 2. So what you want to do is you want to look at it, when you're going to integrate with respect to y, you need to look at it sideways. So over here are the greater values of the function, right? So when you're thinking about the function with respect to y, because again, the value of the function is the x value. So look at it like you're going from the lowest x value, or sorry, the lowest y value, which is right here, right? So to get this area, I'm going to be going from this y value, in this case 0, right? All the way to the highest y value, right? Which is 6. Well, notice what happens in between there. The functions change, right? So you have a change in the function. So from, notice right here at y equals to 4. So notice to find the first section from 0 to 4, what functions am I going to subtract?
X equals 2y.
It's going to be, the greater function is the green, right? Notice the purple is not in the picture at all, right? For that section. So from 0 to 4, I'm looking at the green function, which is 2y, minus the orange function, which is y, dy. Does that make sense? That's the first section of the area. Plus, what's the second integral? From 4, so from again y equals 4 to 6. But this time, which function is on the right?
12 minus y.
It's the purple, right? 12 minus y minus 12 minus y minus the orange again, right? So that's the area if we're finding it with respect to y. And again, that would not be difficult to integrate, right? Do you guys agree? So, and then if we do it with respect to x, what would that look like? So now notice, what are we looking at? What's the smallest x value? Where do we start? At x equals 0, right? But this time we're looking at it left to right, right? So x equals 0 to, in this case, 6, right? So now we're looking at stopping right here at this point right here, right? So what do I do there? From there, which one's the greater function? It's the orange, right? Which is x minus the green, which is x over 2, exactly. With respect to x this time, right? So notice now we had to solve for y, right? Because now y is the value of the function when the function is with respect to x. And then to that, we are going to add the integral from x equals 6 to 8. Yep. And then on that interval, which one's the greater function? From x equals 6 to x equals 8. The greater function is the purple, right? The purple function is greater. So 12 minus y, but I'm not going to write 12 minus y, right? You have to solve for y. So it's going to be 12 minus x. And then take that minus the green, right? Which is x over 2 dx. Okay. Now notice the two integrals we have 4 integrals, right? But the two areas, do they look similar at all? I mean, they have some of the same stuff, but they're completely different. I mean, they're, one's from 0 to 4, then 4 to 6, the other one's 0 to 6, 6 to 8. The variables themselves don't matter, but the functions are different, right? So should we check to make sure that those two are actually equal? We should, right? That's always a good idea. So we won't do it by hand because that's tedious, but we'll get our good buddy over here to do it for us. All right, let's find the first one. Integral from 0 to 4 of 2y minus y dy plus integral from 4 to 6 of 12 minus y dy. Okay, so we could have simplified that a little bit, but... All right, so what does that say? 12. Does that look right? Okay, we'll write it down. 12. Okay, so integral from, let's do the second one, 0 to 6 of x minus x over 2 dx plus the integral from 6 to 8 of 12 minus x over 2 dx. All right, what does that say? Snap. What do you think about that? We did it. We did it right, for starters. But they're both 12, right? This guy's 12 and that one's 12. And notice this one, one or the other isn't any easier, right? So it's just it just depends. Sometimes one is easier than the other, and sometimes you just go with whatever floats your boat. But so now that we have it up, do you think we could have figured this out without having the picture? No. Not really, right? There's a lot of stuff going on there that it would be easy to accidentally subtract the wrong functions if you're not looking at what you're actually trying to find the area of. So what's always the first step? Draw a picture. Okay, good. Any questions? No? Sure.